Okay, good morning, class. Today we will be discussing our last topic in prelims. So, module 6, we have lateral earth pressure. Okay. So, lateral earth pressure is as retaining structures such as retaining walls, basement walls, and bulkheads commonly are encountered in foundation engineering. So as they support slope of earth masses, so proper design and construction of these structures require thorough knowledge of the lateral forces that act between the retaining structure and the soil masses being retained. Okay, so yung ang lateral earth pressure is uh, kung ano yung na-experience ng retaining structures natin. So we have different retaining structures. We have retaining walls, basement walls, bulkheads. Okay? So anything na nagso-support ng slope soils or slope of earth masses. Let's say you have this sloping ground, horizontal sloping ground, and kunyari this time maglalagay kayo ng roads dito. Gagawa ka ng roads dito. So you need to design this lateral or this retaining structure to hold this slope soil, to hold this sloping soil or this earth masses. Okay? So for example, may foundation tayong malaki. So for example, gagawa tayo ng gagawa tayo ng foundation. Let's say we have mat foundation. So sometimes if you're a structural designer for the building, ang nangyayari kasi kung sino yung nagde-design ng building, hindi naman siya nagde-design ng retaining walls. Pero there is this special structural engineer, yung mga ang dine-design lang nila is retaining walls such as mga sheet piles. Okay, so sila yung para sila specialty contractor. Okay, so specialty contractor, they have their own structural engineer, and since they are the one who will create who will sila yung magpo-provide ng retaining walls or the sheet piles, sila na rin yung nag-design. So parang design and build na sila. Okay, so these lateral forces caused by lateral earth pressure. So the magnitude and distribution of lateral earth pressure depends on many factors. Syempre, you have the soil, grade, mass of soil, okay, na i-retain mo. Let's say this was SH. So meron niyang force na tutulak. There is this lateral force na tutulak dito sa ating retaining structure. That force, that lateral force, we call it a lateral earth pressure. Okay, so there is a relationship. Okay, there is a relationship between the lateral force and the effective vertical stress. Okay, dito sa ating soil. Okay, so later we will be discussing what is that relationship. Okay, so what are the factors that affect the lateral earth pressure? We have this shear strength. Okay, so the shear strength of the soil that is being retained, the inclination of the surface of the backfill, the height of the inclination, okay, the nature of the wall movement under lateral pressure, the assumptions, okay, if going to the left or going to the right, and adhesion of internal friction angle between the wall and the backfill interface. Okay, ang mangyayari kasi dyan is they have this shearing line, this one. Syempre, kapag natumba tong ating retaining structure, this soil, this portion of soil, okay, this portion of soil it will shearing off. Okay, this one. This portion of soil will shear off. So kapag hindi stable yung ating retaining structures. Okay. Then we have this lateral earth pressure. So in other words, the lateral earth pressure is the pressure between the retaining earth and back of the retaining structure. Okay, so later we will discuss how to solve for the lateral, what are the formulas and what are the equations to solve for the lateral earth pressure. Okay. There is this different structures that subjected to lateral earth pressure. This is the retaining walls. We have the basement wall. We have the brace excavations, and we have sheet piles. Okay, so maybe next meeting we will discuss example problems in dealing with dealing with structures that subjected to lateral earth pressure. So since you are focusing this class is focusing on structural engineering side, okay, we will focus more on these structures that subjected to lateral earth pressures. Okay, so we have different retaining walls. Okay, we have sheet piles and we have brace excavation. Okay, so some structures subjected to lateral earth pressure. This is a sheet pile. So this is an example of a sheet pile. Okay, so this is a sheet piles. So this time, they have this excavation for their foundation. Let's say their foundation is a mat footing with a very thick mat footing, or maybe they have their foundation solution is piles. Okay, so they have this excavation length. And syempre, hindi naman lahat yan dapat is kailangan mong excavate. So you have to retain yung kabilang soil. So this is a sheet pile. Yan, mapapansin mo steel yan na dugtong-dugtong or connected. They are connected. Again, they are sheet of steel. Okay, that is a sheet pile. Okay, so as you can see, this length age is approximately 5 stories of excavation. Then we have this earth retaining walls, concrete retaining walls. Okay, examples of concrete retaining walls. So what are the assumptions of the retaining structures in taking the lateral earth pressure? So we have three assumptions. We have at rest pressure, this one. So you need have this at rest pressure. You have this active pressure, and you have this passive pressure. So you have three assumptions. Okay. Active soil pressure, this time, active soil pressure is a lateral pressure exerted by the soil. Okay, so this is the soil. The forces exerted by the soil to the earth retaining structure that causes a slight movement away, okay, away from the retained soil material. So for example, this is your retaining walls. Ito yung retaining walls mo. Okay. So the assumptions are your retaining walls slightly move away from the earth retaining structure. So that is the assumption. Okay. So you have this delta, which is delta L sub A. Okay. What is passive? Passive is a lateral pressure exerted by the soil that causes a slight movement of the wall towards the retaining structure. So the assumptions here is you have a this is your retaining wall or retaining structure. Okay, and the assumptions are you move the retaining structure moves towards the retained soil this time. So, kailan ba nangyayari yung moving away or moving towards? Okay, so yung this time, yung moving towards, mangyayari to kapag medyo lakas yung lateral pressure mo dito sa ilalim. Okay, so syempre, pag mas malakas yung lateral pressure mo sa ilalim, tutulak niya yung ating retaining structures and moves towards sa retained soil. This time naman, yung moment na nakakos niya dito sa may upper portion, so for example, the centroidal distance, let's say you have this centroidal distance at the center, okay, the forces at the top, the lateral forces at the top is much greater than the lateral forces at the bottom. So we can assume that that is a lateral, that is an active pressure. So to memorize the active soil pressure that is away and the passive soil pressure that is towards. So just memorize this active letter A and away. Okay, so that if that is away, that is an active soil pressure. And also we have this at rest pressure. Okay, at rest pressure is assume there is the movement is negligible, and the assumptions is the retaining structure is does not causes a slight movement. The lateral pressure that not causes a slight movement in the walls. So we have this at rest pressure. Okay, so then this blue line over here, this one and this one is the shearing line or yung failure plane natin. So as you can see, we have this formula again, and this formula. Okay, so this time this failure line or failure plane. Okay, we assume that this soil, if our retaining structure fails, okay, this soil, this portion of soil will shear off. Okay, again, if this time, as you can see, steeping, mas malaki yung soil na shear off when active pressure. Okay, this time, yan. So that is an active pressure. Okay, and if you check an element, or if we check an element or stress element inside this portion, okay, we have this ayan, this is our stress element. Okay, so the stress element is very basic. We have this over effective stress. Okay, the stress due to the soil at the top, and we have this lateral pressure or lateral earth pressure, which is denoted as sigma prime H. Okay, again, there is a relationship between the lateral earth pressure and the effective vertical stress. We call it the coefficient of lateral earth pressure. Okay, so again, the relationship of the lateral earth pressure or the horizontal force or the horizontal vertical stress to the vertical effective stress is what we call the coefficient of lateral earth pressure. Okay. So the Rankine earth pressure theory. So according to Rankine active earth pressure theory. So if you recall what I shown you in the last module, so we have different failure theories. So we have failure theories based on brittle materials, and we have failure theories based on ductile material. So last time, the brittle material, okay, so according to the failure theories in last meeting, we used the Moore column, okay, Moore column failure criterion or failure theories in shear strength of the soil. This time, we have this Rankine theory to determine the capacity or determine the failure theories, the failure in dealing with lateral earth pressure. Okay, so in other words, the theory of Rankine failure theories is used in lateral earth pressure. Okay, so we have this notation. So at rest pressure, we call it delta sigma H, rigid and unyielding, no lateral strain, wall is static, no movement either to the right or to the left, and state of elastic equilibrium. And we have this active pressure, we call it sigma A. So wall is moving outward a short distance, okay, or away, moving away from the soil mass gradually. Okay, And we have this passive pressure. We denote the symbol sigma sub p. This is opposite of active condition. Wall moves into the backfill. Okay, so these are the three assumptions. And if we graph the parameters, the variation of the delta LP, or we call it delta L. Okay, uh, the the uh, the lateral deflection to the wall height H. Okay, so delta L is the lateral deformation with a variation to the wall height H. So as you can see, guys, uh, mas maliit lagi yung earth pressure caused by active compared to passive. Okay? So as you makikita rin natin yan dito sa ating diagram. So medyo mas stiff yung soil, yung shearing failure plane in passive pressure compared to active pressure. Okay? So this is also backing up to this graph. Okay, so at rest pressure, the earth pressure delta L, there is no delta L over H, so the at rest pressure is 0. Okay, then if we increase delta L over H, you have this passive earth pressure, passive earth pressure. And if we have delta L sub A over H for active, we have this negative lateral earth pressure. Okay, we have different typical values of delta L sub A over H and delta L sub P over H depends on the soil type. Okay, for loose sands, we have this value. For dense sand, we have this value. Soft clay, we have this value. And for stiff clay, we have this typical values. Okay, so we have different earth pressure coefficients since we have three assumptions. We have at rest, active, and passive. So therefore, we have three coefficient of lateral earth pressure. Okay, so the coefficient of lateral earth pressure for at rest, for at rest, for passive, and for active. Okay, the earth pressure coefficient is K sub O for at rest, K sub A for active, and K sub P for passive. Okay. So the coefficient of lateral earth pressure, or the earth pressure coefficient for at rest lateral earth pressure assumption. So the general formula is the horizontal effective stress over the vertical effective stress. So this is the general formula for K. Okay, this is. Then there is this assumptions based on Jackie 1944. So research by Jackie 1944, and this is uh, widely used assumptions for the lateral earth pressure for K sub O. Even in the board exam, this assumption by Jackie 1944 is used by the examiner. Okay, so for coarse grain soils, your K sub O, or your lateral earth pressure coefficient, is equals to 1 minus sine phi, where your phi is the drain angle of friction. Then for a dense and compacted sand backfill, so if we integrate the effect of compacted and sand backfill, so we have this equation based from Jackie 1944, and we added this equation over here. So if you recall, you have this gamma D, or the actual compacted dry unit weight of the sand behind the wall, and you have this gamma D mean, is the dry unit weight of the sand in the loose state. Okay, so this is included in your geotechnical engineering one, your gamma D mean, your gamma D. Okay, so gamma D mean is the dry unit weight in the loose state. So again, this is the assumption is we consider compacted sand backfill. Okay, then we also have value for lateral earth pressure K sub O, considering the consolidation settlement. Okay, so this time your K sub O will equals to 1 minus sine phi, and there is this value OCR multiplied by OCR raised to sine phi. If you recall, the OCR is the over consolidation ratio. Okay, so this happens if our soil is overly consolidated. So OCR is the ratio of the pre-consolidation to the effective overburden stress. Okay, so that is this one. So if your soil now is normally consolidated or overly consolidated, we also have this relationship. So KO over consolidated for over consolidated soil is equals to K sub O for normally consolidated soil times square root of OCR. Okay, so these formulas, this one, and this one is widely used formulas for determining the lateral earth pressure coefficient of at-rest soils. Okay, so just remember these three formulas, and you can also, if you want, you can also use these formulas. Okay, then for active lateral earth pressure coefficient, okay, the symbol for the coefficient of lateral earth pressure at active is K sub A. Okay, we denote is at K sub A. So if the wall AB move away from the soil mass, the horizontal stress will decrease. Okay, so again, if your walls move away, okay, if the soil move away from the soil mass, okay, the horizontal stress will decrease. Okay, uh, since meron na siyang meron nang nag-loosen up, para nag-loosen up yung soil. Therefore, kung nag-loosen up yung soil dahil may your earth structure is moves away, ang mangyayari kapag nag-loosen up, mababawasan yung horizontal stress. Okay? Different yan sa case ng passive. Bakit? Kapag yung passive nag-move towards the soil, so mas na-compress niya yung soil kasi pumasok siya eh. Mas na-compress niya yung soil. Then ang nangyari, kung pumasok siya, mas nako-compress yung soil, therefore yung horizontal stress is mag-increase. So that is the difference between the active and passive. Okay, so we also have this again, we also have this general equation. The general equation is that K is equals to the ratio of the horizontal to of effective over vertical stress. Okay. So again, K sub A can be derived from the stress condition represented by Mohr circle. So kanina, di ba nakita nyo, you have this line angle failure plane in the soil. So if you consider that angle or failure plane, we can derive to this equation. Okay, so we have this for horizontal backfill, meaning the soil is no inclination, or your soil is horizontal. So let's say, for example, this is your earth retaining structure, and you have this horizontal soil. Okay, horizontal soil. So if your soil is horizontal, your K sub A is equals to tangent squared 45 minus phi over 2. Please take note of the sign minus phi over 2. So using trigonometric identity, the tangent squared 45 minus phi over 2, or the tangent squared theta, is equals to 1 minus sine phi over 1 plus sine phi. Again, please take note of the sign. Okay? Then for sloping backfill, so sloping backfill is have this one, it's like this one. Okay, there is a slope in the ends of your retaining walls and the soil. So they have this slope delta A. So this is, again, this is a soil. Okay. you have this slope alpha. So for sloping backfill, the formula for K sub A is equals to cosine alpha multiplied by cosine alpha minus cosine squared alpha minus cosine squared phi over cosine alpha plus square root of cosine squared alpha minus cosine squared phi. So you're again, take note of the sign. You have negative and you have this positive sign in the denominator. Okay. Your alpha is the angle between the horizontal backfill to the sloping backfill. Okay, that is the line. That is the angle alpha. Okay, so there is a slightly tilt or in the horizontal stress. That is why you have this stress transformation from inclined force to horizontal force. Okay, so you can check the derivation in the book of principles of the Braha-Emdas for this equation and for this equation. Then for active lateral earth pressure, considering a wall friction, okay, so during the 1700s, columns also make the assumptions in the lateral earth pressure. Okay, so according to the theory made by columns, if we consider a wall friction alpha, take note alpha is different. Alpha is different from this alpha, yung alpha na yan. Yung alpha na to is the wall friction or the angle of wall frictions. So the wall friction is the friction between your soil and your earth retaining structure. If we consider that, okay, column earth pressure theory will be used. Your K sub A is equals to cosine squared phi over cosine of the wall friction angle multiplied by 1 plus square root of sine phi plus alpha sine phi over cosine alpha squared. Okay, so that is the assumptions made by columns. Okay, then we also have passive lateral earth pressure K sub P. Again, we have this general formula. K sub P is equals to the ratio of the horizontal stress to vertical stress. Okay. Again, Kp can be derived from stress condition represented by Mohr circle. Then for horizontal backfill, you have this equation over here. So the same equation but different sign. So this time you have positive, positive, and negative. So take note that positive because because the lateral earth pressure due to passive action increases the horizontal stress. Okay, that is why your numerator will increase. That is now positive, and you have this positive angle. Okay, so nag-add yung angle mo. Okay, so for sloping backfill, we also have this equation. So tumaas din, naging positive yung numerator, and the denominator will now become negative. Okay, and the same for columns pressure theory. Your K sub P is equals to this equation. So they are the same. Okay, we have this mnemonics during our board exam review. So passive is, you have this passive that is equals to letter P, positive. Okay, and kapag active, you have this A that is away. Okay, that is our mnemonics in the board exam. So as you can see, they have the same formula. Okay, they have the same formula but different signs. Okay, so so yan. For the pressure diagram for one layer of soil, so how to draw the pressure diagram. Okay, so please note that each layer each layer of soil have different phi and thus need to consider independently. So ibig sabihin, kapag meron kang a retaining wall and you have different soil layer, let's say you have sand, you have your clay, okay, this time, you have different angle phi or the drain angle of friction since they are different soil. So you have phi sub 1, let's say this is phi sub 2, and you need to draw each layer or each layer as one pressure diagram. So ganito namin sinasolve to. So you need to draw, let's say this one, you have this pressure diagram. Okay. First assumption is all layers is sand. Then again, next condition is there is a slight increase due to clay. Then you have this lateral earth pressure. Okay, so that is the assumption. So next meeting, Monday, we will see how to draw this pressure diagram. So there is many ways in solving for the lateral earth pressure. They have this equation base this time. Okay, so ang gagawin natin, we have this drawing ng pressure diagram. So what are the contribution of each uh, contribution of soil, contribution of cohesion, contribution of surcharge, and contribution of water to the lateral earth pressure. Okay, so for example, this time I have a soil. This one is a soil. Okay, so the pressure due to the soil is this time increasing. So para din siyang para siyang dams. Okay, yung nag-analysis of dams kayo. So at the bottom, you are increasing your pressure. Okay, you have this pressure. So if you recall, your K is equals to lateral or horizontal. So let's say horizontal divided by okay, this time should be horizontal divided by vertical. So for the horizontal stress is equals to K times horizontal stress, vertical stress. Then the vertical stress is we use effective vertical stress, that is sigma gamma prime, which is the submerged unit weight of the soil or effective unit weight of the soil, okay, multiplied by the height h. Okay? So your K is nagbabago lang yan, depends kung ano yung assumption mo, kung at rest, kung active or passive. Okay? So for the soil, so we have this the lateral pressure due to soil. So as you can see, your PS or the pressure at the soil is K times gamma prime times H. Your K may be K sub A, maybe K sub O, or K sub P. For cohesion, okay, for the cohesion is the contribution due to cohesion is given by the equation 2C square root of K. Okay, your C is the cohesion stress or cohesion value, and your K is maybe K sub A, K sub O, and K sub P. Okay, the contribution due to the surcharge load Q is given by P times Q. Or P sub Q. Okay, then your P sub Q is equals to the cohesion coefficient K multiplied by the surcharge load Q. Okay, and for the water, the coefficient of lateral earth pressure does not affect the contribution of water. Therefore, the contribution of water is gamma water times HW. Okay, then please take note that the active pressure, okay, the soil and cohesion are different in direction. Okay, so therefore kapag different yung direction nila, the soil, your P sub S will minus or will subtract to P sub C. Okay, then for passive pressure, the soil and the cohesion are the same in direction. So therefore, your P sub S will be added to P sub C. So parang assumption lang natin kanina that yung passive is always greater than the active. Therefore, yung cohesion mag-a-add dun sa due to soil. Okay, so different direction this time. Okay, so that is how you draw the pressure diagram. For your homework, reading homework lang. So just practice now how to solve for different problems in lateral pressure. So review on your own. So just practice or just read different problems in lateral earth pressure para pagdating ng example problems natin, you can easily follow the solution flow. Okay, so for the reference of our discussion, you can check this book and also check this book by Das again by Principles of Geotechnical Engineering. And okay, so that's it. No, so do you have any questions, class? Okay, sige. So next meeting Friday,